Hi, today's video we're going to look at different trig ratios. So the three ratios that we're going to look at are sine, cosine, and tangent. Notice that we're taking sine of an angle, so whatever angle we're referencing, sine is equal to the opposite over the hypotenuse. So we looked at yesterday how to determine which side was opposite, which side was the hypotenuse. Now sine is the trig ratio that relates those two sides together. The cosine is the adjacent side over the hypotenuse. And tangent is the opposite over the adjacent. So express each trig ratio as a fraction. Well, we look here and I've got a right angle. I've got 3, I've got 4. I can find that third side by using Pythagorean theorem. Anytime you have two of the three sides with a right angle, we can use Pythagorean theorem. So 3 squared plus 4 squared is equal to that hypotenuse of AC squared. 9 plus 16 gives us 25 equals A squared. We square root to find that that hypotenuse is going to be 5. So this is asking us for the sine of angle A, which means that angle A is the reference angle. So if I'm looking at angle A, we have 4, which is opposite, 3 is the adjacent, and 5 is the hypotenuse. The sine, according to our trig ratio, is opposite over hypotenuse. So I look, the side opposite is 4, the hypotenuse is 5. So sine of angle A is 4 over 5. If I want cosine, cosine is adjacent over hypotenuse. So based on the reference angle A, the adjacent side is 3 over the hypotenuse, which is 5. And then our last trig ratio is the tangent. Tangent is opposite over adjacent. So here's my reference angle. Opposite is 4. Adjacent is 3. So all of these again are in relationship to angle A. The next set is looking at sine of C, cosine of C, and tangent of C. So I'm switching trig functions here. So now I want C to be my reference angle, which means this is now my opposite side. This is now my adjacent side, but this is still my hypotenuse because the hypotenuse is always that side opposite that right angle. Sine still has that same relationship, so it's still opposite over hypotenuse, but now the opposite side is 3 over the hypotenuse of 5. With C as my reference angle, the adjacent side for cosine is going to be 4 over the hypotenuse of 5. And with C as the reference angle, tangent is opposite over adjacent, which is going to give us 3 over 4. So you do have to know and memorize that sine is opposite over adjacent, cosine is adjacent over hypotenuse, and tangent's opposite over adjacent. One little phrase you may have learned or heard before is Sohcahtoa. Sohcahtoa. And that is sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Just an easy little acronym to help you remember the ratios of your three trig functions. All right, so moving on. What is the acute angle that corresponds to the following trig ratios? So sine, we know that the relationship of sine is opposite over hypotenuse. So if I'm trying to find out the reference angle here, because sine of what angle is 24 over 25, 24 has to be that opposite side and 25 is the hypotenuse. So I know that this is the hypotenuse and this is opposite. So I'm asking, what angle is 24 opposite of? Well, that is angle F. So it's sine of angle F is 24 over 25. When we move to the next one, tangent of what angle is 7 over 24. And so we think about what the tangent ratio is. Tangent is going to be opposite over adjacent. So this time we want 7 to be opposite of the angle and 24 to be adjacent, which is going to be D. 7 is opposite and 24 is adjacent. So I was taking the tangent of angle D to get that relationship. So again, it comes back to knowing sine is opposite over hypotenuse, tangent's opposite over adjacent, so that you can figure out which angle you use to reference that ratio. Next, we have used trig ratios to write an equation that describes DO and over DG. So here is our segment DO, and here is our segment DG. Well, the easy thing is DG only has one option. DG is the hypotenuse. So I want to think about how I can relate these pieces together. I'm going to pick a reference angle. So if I have G, DO is opposite, and that's going to be my hypotenuse. So the trig function that is opposite over hypotenuse, we look above, and that is going to be sine. So it's sine of angle G is the opposite side of DO over the hypotenuse of DG. Again, opposite over hypotenuse, because that side that we were looking for, DO, is opposite angle G. But now if I switch it up, and instead of picking angle G, if I had picked angle D, D is adjacent to DO. So now instead of looking for opposite over hypotenuse, I'm looking for adjacent over hypotenuse. And that is our cosine function. So cosine of D is DO over DG, giving us that adjacent over hypotenuse. So there's actually two different trig functions I can write based on that ratio. I'm either looking at the sine of angle G, or I'm looking at the cosine of angle D. If I change my reference angle, I have a different trig function. All right, next one, and this is an important question. If sine of angle A is 5 over 13, what is the tangent of angle A? Hint, draw a triangle and label the sides you know. So we start. If I have sine, cosine, tangent, if I have any of those trig functions, I know I have a right angle. I can't have sine, cosine, or tangent unless I have a right triangle. So I have the angle A. If I'm doing sine of an angle, it cannot be the right angle. So you can pick any other angle you want, it just can't be the right angle. Now sine is opposite over hypotenuse. So if this is my angle A, opposite A is 5, the hypotenuse is 13. So now I've got my triangle set up. I'm using A as my reference angle. Now I want tangent of angle A. Well, tangent of angle A is opposite over adjacent. The opposite side is 5. We've got that. We've got the hypotenuse. What I don't have is that adjacent. So I have to find the adjacent side. We have to think old school for this. Again, if I want to find this missing side, I have two sides of a right triangle. We do Pythagorean theorem. X squared plus 5 squared is equal to 13 squared. So that's x squared plus 25 equals 169. X squared equals 144. We square root, and we find x is going to be equal to 12. So that becomes 5 over 12. So our answer here, the tangent of angle A, is going to be 5 over 12. It's really important that you draw that picture. That picture kind of helps bring everything into place. So to review everything, if I give you the question, given cosine of something is equal to 3 over 5, what am I asking you to solve for? I'm asking you to solve for the missing reference angle. If I have given tangent of angle B is equal to blank, what are you solving for? You're solving for the missing ratio of sides. And in this case, because it's tangent, we are looking for the opposite over the adjacent side. So you got to pay attention. Are you solving for the reference angle or are you solving for the ratio of sides based on the setup? It's always the trig function of the angle is equal to the ratio. And that finishes up today's video.